So here we are with part 8 of 23. So students will distinguish between alternating current and direct current in terms of electron flow and electron field. So what is the difference between them? Well, symbolically, our direct current is denoted by a battery or a cell, where we have the positive side with the long line, the negative side with the short line, so the electrons would be repelled from the negative and come back to the positive. Again, that's electron flow. The actual current convention is to have a positive current. Really, it's Ben Franklin's fault. He's the one that rubbed a rod against a piece of rabbit fur and said, okay, this side's positive, that side's negative. Had he just arbitrarily chosen it the other way around, pretty much everything we've ever done in circuits ever since would be so much easier. But this is direct current. The electrons will flow one way and one way only, usually at a fairly steady pace, so we'll have a uniform electric field over time. At least if we're doing a time scale short enough that we don't really notice the battery losing power, we are going to have a uniform electric field. Now, if instead we have alternating current, which has that tilde symbol in it, well then the electrons start going one direction and then go back the other and go back this way and go back that way and go back this way. So, it's not one direction, not the boy band either, but it's not flowing in a single direction. If we were to look at the electric field or the electron flow over time, it's best not to have the axis at the bottom of our diagram, because we're going to be seeing this sinusoidal pattern, because it's going to be based on the sine and cosine functions. Now, there are things that we can do to prevent that. There's things like rectifiers. So there are some things that can they will reverse the current again on the inside. So you have this shape. Rectifiers just only allow electrons to flow one way. So we have current and then no current. So we do have a few options, but this is the core. DC gets a consistent value in electric field, whereas AC will go back and forth and back and forth. So household current is alternating current, which does have some issues. We actually have a higher likelihood of dying from electrocution in North America than they do in Europe, because this frequency of our alternating current in North America is a little closer to the natural frequency of the heart than it is in Europe, so it's more likely to induce a heart attack and stop your heart. There's other issues. A strong case could be made for having gone with direct current instead of alternating current in the first place, but Thomas Edison had a better public persona than Nikola Tesla when these arguments were happening, so Edison won, even though Tesla was definitely the superior scientist. I would actually recommend, if it's ever convenient, pick up a good biography of Nikola Tesla and read about him.